So our physics project deals with the principles of energy when you're bouncing a ball. Just to give a little introduction to the experiment, what our experiment does is it covers concepts of potential energy and kinetic energy when you bounce a ball. Basically what we did was we bounced a volleyball and found how determining the potential and kinetic energy could predict the height, and then compare this to the experimental height that we actually found. By determining the velocity of the bounce, we could find the maximum predicted height through energy equations. The reason we were able to do this was through the principle of conservation of energy, because we could set the kinetic energy at the initial part of the bounce to the potential energy at the height of the bounce. So just to show what kinetic potential energy is, as you can see on this hill, when the biker's at the top of the hill, he has potential energy because he's at a height. When he's moving, when you see the energy in or energy out, when the biker starts to move and there's motion, the potential energy gets transferred to kinetic energy, and that's why in the kinetic energy equation there's actually a velocity, because this indicates that it's moving and there is kinetic energy. To go in on the conservation of energy, basically what the principle of conservation of energy states is that energy can't be created or destroyed, but it can transform from one type to another. This means that in the case of our experiment, the energy is transforming from the initial kinetic energy to the final potential energy. This is the reason we're able to set the initial kinetic energy after the bounce equal to the potential energy at the height of the first bounce. We derive from this the equation Ki, which is the kinetic energy at the start of the bounce, equal to UGF, which is the potential energy at the height of the first bounce. Here's the video of the volleyball bouncing.
Go.
Here's the velocity versus time graph. So as you can see, after plotting the graph, we found that the initial velocity right after the bounce was 4.00 meters per second. So what we did with this was we found the bounce height. So we set the kinetic energy equal to the potential energy. So you can see on the right, mg delta y, which is the final potential energy, is equal to 1/2 mv/y squared, which is the initial kinetic energy in the y direction. We were able to cross out the m's and solve for delta y, which we got as 0.816 meters. Just to show what the variables are, the v was the initial velocity after the bounce in the y direction. The m was the mass of the volleyball, which can be cancelled out of the equation, as it is both in the numerator and the denominator. The g is the gravitational constant, which is 9.8 meters per second squared. And the delta y is the change in height, which is what we're trying to find right now. So after doing this, we also plotted a position versus time graph to find what the actual experimental height was. And as you can see, we found that it was 0.810 meters. So the experimental height was 0.810 meters, and the predicted height was 0.816 meters. So to give a conclusion, as I just stated, the predicted height and the experimental height were actually very close to each other, only differing by 0.006 meters. These similarity of values show that the ideas of conservation of energy can be applied to predicting the height of the bounce, because we were able to set the initial kinetic energy equal to the final potential energy and actually get a very similar height.